Hey you guys, so I heard that you had some more questions about, not necessarily about MDRS or what we're doing here, but about Mars in particular. And one of those questions was regarding gravity on Mars. So that's a pretty big question. I was just going over that with my 7th grade class. So you guys are asking some pretty good questions. Gravity on Mars compared to gravity on Earth and the Moon, for instance. Gravity is a result of the gravitational pull, of the force of gravitational pull. It's different from weight and it's different from mass. Mass is the amount of material that an object has, and weight is the gravitational pull number on you. So if you weigh 100 pounds on Earth, for instance, on the Moon, you are only 16.5. The Moon has 16.5% of Earth's gravity. Earth's gravity is 1 or 1.0 or 100, and the Moon's is 16.5% or 0.165, or you could also say 1/6, because 16.6 is about 1/6 of 100%. So if you weighed 100 pounds on Earth, you would weigh 16 pounds on the Moon. Your mass would still be the same. You would still be the same object, the same entire full person, but because the gravity is different on the Moon, you would weigh different on the Moon. You would weigh lighter because gravity is lighter. For Mars, Mars has 37.6% of Earth's gravity, or 0.376, which is 37.6%, or you could say 38%. Most people just say it's 1/3 of Earth's gravity, which would actually be 33.33%, but it's a lot easier to say 1/3 of Earth's gravity. So on Mars, if you weighed 100 pounds on Earth, you would weigh 37.6 pounds on Mars. And so the reason why the Moon is actually orbiting Earth is because of Earth's gravity is holding on to it and keeping it in orbit. Mars has 2 moons, Phobos and Deimos, which are really just asteroids that were flying by Mars and got caught by Mars' gravitational pull. And every object in the universe has gravity. So that means you and I both have gravity, or gravitational pull. But because we are so much smaller in relation to other things such as Earth, our gravitational pull is not recognizable. You can't really see us. If I took a ball and stuck it next to you, the ball is not going to fall towards you or orbit you or go around in a circle around you, because our gravitational pull is not big enough, because we do not have enough mass to hold anything in orbit or to draw anything towards us because of gravity. And so you can simplify it by saying the bigger an object is, the more gravity it has. That's not exactly true, but this is a simple explanation of it. For instance, if you had a balloon that's one size, a kickball that's the exact same size, and a bowling ball that's the exact same size. A bowling ball would have a greater density. So if you scale those things up to the size of a planet, then the bowling ball would have greater gravity, even though it would be the exact same size as the balloon and the kickball. But that's another topic for another day that we don't have to go into right now. So that is the explanation of gravity. Hopefully that answered your question. I think that's what your question was for sure. Yes. So to answer your question, yes, gravity on the Moon is less than gravity on Earth, about 1/6 of Earth's gravity. And so yes, there is gravity on Mars, because every object in the universe has gravity, and Mars just happens to have 37.6, or 1/3 the amount of Earth's gravity. believe someone else had asked a question about an anti-gravity machine to experience space here in MDRS, or for any Mars analog simulation, pretend a scenario that we're in. The answer to that would be no. Anti-gravity does not really exist. You can create gravity where there is none. For instance, in space, if you're flying between Earth and Mars, the astronauts would be weightless because of the way physics work in space. However, if you've ever watched a sci-fi movie or anything like that, you may see, for instance, Elysium or The Martian or 2001: A Space Odyssey. You always see a circular, a donut-shaped spaceship or space station. And that spaceship or space station is spinning slowly. And that is creating gravity by a thing called centrifugal force. So a really easy example of this is if you take a bucket of water and you start spinning it like this. If you spin it over your head, the water fast enough. You have to do it fast enough. You can't just take it and hold it over your head. But if you spin it fast enough, the water in the bucket would feel a force going away from you, outwards from you as the reference point of the force. The water would be trying to go outwards, but because the bucket is stopping it, the water is going to stay with the bucket, but it's going to stay in the bucket as it goes around. So that's what is the idea behind those spinning space stations, is that if you can spin it at a certain speed, depending on the size of the space station or spaceship, you can get on that outside edge of the ring. You can get artificial gravity there. But to answer the question about anti-gravity, no, that's not really a thing that we are doing right now. So for how we plan on traveling on Mars, someone asked about taking ATVs. No, we would not be taking ATVs, at least not the ones that we have here on Earth. NASA's been working for the past couple of years on rovers, kind of like a little go-kart buggy thing that's covered, that the astronauts can travel around on the surface of Mars and be inside, kind of like a giant car. And so they could have air inside, so they wouldn't have to wear their spacesuits or anything like that. And that is what they would be traveling around in on Mars. At least that's what the plan is right now. Those would be a lot heavier than an ATV. And yes, weight is very important for shipping things off of Earth and landing them on Mars, because Mars only has 1% the atmosphere, the thickness of the atmosphere that Earth does. So it's a lot harder to slow down going into Mars atmosphere. The Earth, we slow down. You see the space shuttle, or you saw the videos or heard about things hitting the atmosphere and the fire coming up around them. But the part of that was it was slowing down because of the thickness of the atmosphere. It was trying to push through, and the atmosphere was slowing it down. Mars does not have that thick of an atmosphere, so the weight wouldn't matter would factor into the speed and everything to slow an object down on Mars. So you can't ship, as currently, you cannot ship things that are too heavy to Mars, because we don't have a way to land them safely on Mars. So another question was, why is Mars red? So Mars, a lot of people think that Mars is red because it's hot. Actually, it's not hot at all. The average temperature is negative 81 degrees Fahrenheit, or how you would refer to it in science textbooks and whatnot, it would be negative 36 degrees Celsius. So Mars is pretty cold, and part of that is because it's further away from the sun. Another part is because its atmosphere is not as thick, and that's just there's a number of factors as to why it's cold. So the average temperature is negative 81 degrees Fahrenheit. Its highest temperature is 95 degrees Fahrenheit. So that is, I mean, if you go out in the summer in Columbus or anywhere in Ohio, 95 degrees isn't, anything too unbearable. You go to Florida, 95 degrees is, you could say that's the, consistent temperature down there. But in Ohio, 95 degrees is, it's pretty okay. It's hot, but it's not burning hot like everyone thinks that Mars is. So Mars is actually red because the regolith, as Renee was explaining to you, the regolith, or what we would call here on Earth the dirt or soil on Mars, is actually full of iron, or rather iron oxide, which is another name of that is just rust. And so the same rust you see on a car or on a bike that's been left outside or anything like that, it's just rust. And so all the dirt on Mars is rusted, and so that's why it has the red color to it. Your other question was, why is there not a lot of water on Mars? Well, actually, there is actually a significant amount of water on Mars. If you ever look at a picture of Mars, you'll see that it has a north and south pole, and it has ice caps on the north and south pole, just like Earth does. Those ice caps are full of mostly H2O water. Some of it is frozen carbon dioxide, but most of it is H2O water. And if you were to melt all the water in the ice caps, you would cover the entire planet in about 11 meters or 36 feet of water. So that's 36 feet would be, if you have a 4-story building with 4 floors on it, it would be about that high or that deep, depending on how you're looking at it. So there is a lot of water. You don't see any flowing water on Mars, which might be what your actual question was, because again, the atmosphere is not very thick. So it doesn't exert as much pressure on the water molecules as Earth does. So if you take your one hand and grab your arm like so, and you squeeze, that is pressure that you are exerting or applying or administering to your arm. And then when you let go, you're releasing that pressure, or there's no more pressure on your arm. And so that is essentially what the air in the atmosphere is doing to everything on the surface of the planet, our Earth. And so under regular pressure from the atmosphere, water will stay liquid at a certain temperature. However, on Mars, because it's colder than freezing, water wouldn't, if you had that temperature on Earth, water would freeze. However, because you don't have the atmospheric pressure on the water on Mars, the water immediately turns into a gas vapor and will sublimate or evaporate into the atmosphere. And then again, with the solar winds, the sun is pushing out. The sun is like blowing, as you would blow out a birthday candle. The sun is blowing across the entire solar system, and so it is blowing away Mars' atmosphere, and that is partly why Mars does not have as thick an atmosphere as Earth, because it is not, its core is not spinning. It's going into a lot of detail, but we have a lot of hot metal in the center of Earth, and it's spinning, and that is causing a magnetic field, which essentially an invisible force that is keeping harmful stuff from the sun from attacking Earth. Well, Mars, because Mars' core is more or less frozen, it does not create that invisible force, and so Mars gets hit by all the harmful stuff that Earth does not. And so therefore it loses its atmosphere, and therefore it's not able to keep as warm, and so that's why it's really cold there, and there's no atmospheric pressure, so the water will not stay liquid on Mars, and so it will evaporate, or the water, if it ever got to the liquid point, it would evaporate. But like I said, most of it that's there is frozen in the ice caps. There is some that's also frozen right under the surface, right under the regolith on the surface across the entire planet. So there is actually lots of water on Mars. We just can't get to it right now. another question was, why is Mars dry? Again, so I could kind of just explain that, because it's so freezing cold there, nothing would be able to, it's so freezing cold there, and because the atmospheric pressure is not a lot, nothing can stay liquid there. And so that is partly why Mars is dry. It also doesn't help that the sun is attacking Mars with the harmful material from the sun. So there are a number of reasons why Mars is dry, and why it doesn't have water, and why its core stopped spinning, and why its atmosphere is not there right now, and why it had water before but doesn't have it now. But these are all questions that NASA and other scientists across Earth are currently looking at right now. So if you guys are asking those questions, then you're going in the right step. So I think I went ahead and answered all your questions that we have right now. I'm still at the hab right now, but we will be ending our mission tomorrow, or by the time you see this on Monday, it would have been on Saturday. We'll be ending our mission. So if you have any more questions, definitely feel free to send them back to me. However, I won't be able to answer them at the hab here. I'll have to answer them at home, because I won't be here after Saturday. I just want to say thank you for your questions, you guys, and I look forward to getting some more from you. Okay, and hopefully everything I gave you answered all your questions, and I will try to give your teachers some more information that have some other videos and pictures that can better explain some of the concepts I talked about. Okay, I guess that's it for right now. I will talk to you guys later. Okay, bye.